Hello everyone, good evening. So here we shall solve from question number 16 onwards. During this told, a quadrilateral is a parallelogram with a pair of opposite sides is equal and parallel. So we have to prove this. We draw a quadrilateral. So let's say this is ABCD. ABCD is a quadrilateral in which a pair of opposite sides is equal and parallel. So suppose it is given that the quadrilateral ABCD quadrilateral ABCD the AB is parallel to CD and AB is equal to CD, which means that these one pair of opposite sides is equal also and parallel also. These two sides are equal and parallel. So then we have to prove that ABCD is a parallelogram. ABCD is a parallelogram that we have to prove. So how to prove it? We will draw the diagonal BD. Diagonal BD will be drawn. And then here you can see that these two are parallel and equal. And so the construction is that diagonal BD is drawn. Diagonal BD is drawn. So then the proof. So I will take that in triangle ABD and triangle CDB. In CDB, we have AB equal to DC, which is given. Angle ABD that is equal to angle CDB. Since alternate interior angles are equal, since it is given that AB is parallel to CD and BD is the transversal. BD is the transversal. So I can say that these two angles are equal, angle ABD and angle CDB. And obviously BD is the common side. BD is the common side. So therefore I can say that triangle ABD is congruent to triangle CDB by SAS rule of congruency. SAS rule of congruency. So you can say that angle ADB that is equal to angle CBD. Angle ADB that is equal to angle CBD by CBCD. So now these two angles are equal. It means that they are alternate interior angles. So therefore you can say that AD is parallel to BC also, since alternate interior angles are equal. Alternate interior angles are equal, and obviously alternate interior angles are equal, and BB is the transversal. BB is the transversal. AD is parallel to BC. So therefore, I can say that in quadrilateral ABCD, AB is parallel to DC, which is given, and AD is parallel to BC. It is also proved above. It is also proved above. It is also proved above. So therefore, we can say that ABCD is a parallelogram. Therefore, we can say that ABCD is a parallelogram. Since its opposite sides are parallel to each other. It's both pair, since it is both pair of opposite sides are parallel to each other. Parallel to each other. So hence proof. Then here it is told that ABCD is a parallelogram in which P and Q are midpoints of the opposite sides AB and CD. If AQ intersects DP at S and BQ intersects CP at R, will show that APCQ is a parallelogram. BQ also is a parallelogram, and QR is also a parallelogram. So here it is given. First we will write what is given. So it is given that ABCD is a parallelogram. ABCD is a parallelogram in which P and Q are midpoints of the sides AB and CD respectively. P and CD respectively. And AQ intersects DP. AQ intersects DP at S, and BQ intersects CP. BQ intersects CP at R. So then we have to prove that. First is ABCQ is a parallelogram. ABCQ is a parallelogram. Second is DP. DQ is a parallelogram. Third is SQR. SQR is a parallelogram. Then here the fifth Trigonometry. So we can say that AB equal to CD. AB equal to CD, since opposite sides of a parallelogram are equal. Opposite sides of a parallelogram are equal. So therefore we can say that half of AB that is equal to half of CD also. It means that DQ equals to PB, and obviously AB equals to CQ. Is equal to half of so therefore we can say that in quadrilateral APCQ, AP equal to CQ and obviously AP parallel to CQ. Since here it is given that AP is parallel to DC. It's given. So therefore, in this quadrilateral, one pair of opposite sides are equal and parallel. So hence we can say that APCQ is a parallelogram. So therefore, we can say that APCQ is a parallelogram since it's one pair of opposite sides. So it's one pair of opposite sides which are AP and CQ. So AP and CQ are AP and CQ. They are parallel to each other. It's one pair of opposite sides are equal and equal to each other. CQ is a parallelogram. So hence proof part one has been proved. Similarly, you can say that similarly in it means that from here APCQ we have proved that it is parallelogram. So therefore we can say that AQ is parallel to PC. We can say that AP is parallel to PC also. Sorry, AQ is parallel to PC. AQ is parallel to PC. Since opposite sides of a parallelogram are parallel, opposite sides of a parallelogram are parallel. Similarly, you can see that similarly quadrilateral. Similarly, in quadrilateral DQ, DP, DQ, DP, DQ, ED equals to DQ, ED equals to DQ since ED equals to half of AP, which is equal to this is equal to DQ is equal to half of DC. Also, ED is parallel to DQ. ED is parallel to DQ since AB is parallel to DC, which is given. Therefore, I can say that so DP DQ is a parallelogram. DP DQ is a parallelogram since it one pair of opposite side. It's one pair of opposite sides which are this PP and DQ and DQ are parallel and equal to each other. Parallel and equal to each other. So therefore, we can say that BP is parallel to QB. BP is parallel to QB. Since we can say, since the opposite sides of a parallelogram are parallel, opposite sides of a parallelogram are parallel. Here, so now we can see that now in quadrilateral PSQR, quadrilateral PSQR, you can see that PS is parallel to QR. PS is parallel to QR. Since it is proved, that we have prove that TP is parallel to QB. TP is parallel to QB, so I can say that PS is parallel to QR, and also PR is parallel to QS. PR is parallel to QS. Since there is a QS is parallel to QS, since why? Since PC is parallel to AD. Since PC is parallel to AD, C is parallel to AD. PR is parallel to QS since PC is parallel to AD. So therefore, you can see that opposite sides of quadrilateral PSQR are parallel. So PSQR is a parallel. So therefore, you can say that PSQR PSQR is a parallelogram since it's both pair of opposite sides. It's both pair of opposite sides parallel to each other. Parallel to each other. So hence proof. Hence it is proved that PSQR is a parallelogram, which is the proof of the third part. And here also we have proved the second part, which where we have shown that PQ is a parallelogram. So all the three parts have been proved. And here it is told that the sides DA and DC of a quadrilateral ABCD are produced as shown in the figure, prove that x plus y that is equals to a plus b. Now here the figure which is given, that is like this. One quadrilateral is given. Now this is A, B, C, D. This line is also being extended. Now this is angle A. This is Y. This is X. This is D. So I can say that now given that sides BA and DC of a quadrilateral ABCD are produced so that the exterior angle A that is equal to B and the exterior angle C that is equal to A and angle B equal to X and angle D equal to Y. And we have to prove that let's prove that X plus Y that is equal to A plus B. X plus Y that is equal to A plus B. So the proof is like this, that we know that angle A plus angle B plus angle C plus angle D that is equal to 360 degree is the sum of all the interior angles quadrilateral is 360 degrees. From all the interior angles in a quadrilateral, all the interior angles in a quadrilateral is 360. Now, the exterior angle A, that is equal to 180 degree minus angle A. The exterior angle C, that is equal to 180 degree minus angle C. This is from the linear pair. So the interior angle and the exterior angle will always form a linear pair. So their sum will be always 180 degrees. Since they are from the linear pair. Now therefore, now exterior angle A plus exterior angle B, that is equal to 180 degree minus angle A plus 180 degree minus angle C. Now exterior angle A, that is given as B, and exterior angle C we have to write here. Exterior angle C, that is given as A. So B plus A, that will be equal to 180 plus 180, that is 360 degree minus of angle A plus angle C. Now from here, so now we can see that angle C plus angle C plus angle A, that can be written as 360 degree minus of angle B plus angle D. 360 degree minus angle B plus angle D. Which means it is equal to 360 degree minus of x plus 1. So therefore, A plus B, that is we have found it as 360 degree minus of angle A plus angle C. 100 degree minus of angle A plus angle C. So that will be equal to 360 degree minus of 360 degree minus of x plus 1. So this will be equal to 360 minus 360 plus x plus 1. So these two will get cancelled. So this is A plus B. So therefore I can say that A plus B, that will be equal to x plus 1. Hence proof. And here it is told diagonals AB, diagonals AC and BD of a parallelogram ABCD intersect at O. Diagonals AC and BD of a parallelogram ABCD. Suppose we have a parallelogram ABCD. Now the diagonals is the diagonals BD, the intersect at O. If OA equals to 3 centimeter and OD, that is equal to 2 centimeter, then determine the lengths of AC and BD. Now we know that the diagonals of a parallelogram always bisect each other. I don't know that the diagonals of a parallelogram bisect each other. Each other. So now therefore we can say that from now diagonals bisect each other. So therefore I can say that AC, therefore I can say that the diagonals AC and BD bisect each other at the point O. Bisect each other at the point O.
When these students got under 30, 10, 30, students, but there are 5 more plus 5 plus 15 numbers. 20 students are less than 30. How many students are less than 60 are there? 30 plus 20 is 50. Already 20 students are less than 30. 30 to 60, another 13.
Therefore, I can say that OA is equal to OC, is equal to half of AC, and OB is equal to OD, which is equal to half of BD. So therefore, OA is given as 3 centimeter, which is equal to half of AC, and OD has been given as 2 centimeter, which is equal to half of BD. Therefore, AC will be equal to 6 centimeter, and BD will be equal to 4 centimeter. So the lengths of AC and BD are 6 centimeter and 4 centimeter. So this is now. So hope all of you understood the solutions of all these questions till the question number from question number 16 in exercise 1 till the question number 2 in addition and practice questions. Still any doubts if you have, please write them in the comments. We shall obviously clarify them. So thank you everyone. Bye.